Hi students, exercise 1.3 from chapter number 1 of 10th standard NCERT textbook. First question is prove that root 5 is irrational. We already know that the number root 5 is irrational, but we have to prove this now. Okay, and we are using a theorem called contradiction theorem to prove root 5 is irrational. Let us write the proof now. Proof. By using the contradiction theorem, let's assume that root 5 is rational. Okay, we are assuming just opposite of what we have to prove. Root 5 is rational. If root 5 is a rational number, we can represent it as root 5 is equal to a by b. In a fractional form, we can represent if root 5 is a rational number, and one condition is there for a and b. A and b are co-primes. Okay, this is also our assumption. A and b are co-prime means a and b, they are not sharing any common factor other than 1. Now we can cross multiply this number. Root 5b is equal to a. Okay, after this step we are squaring both the sides. Then root 5b the square is equal to a square. Okay, then root 5b square is 5b square is equal to a square, and rewriting it as a square is equal to 5b square. From this step, what we can conclude? 5 is a factor of a square. That means 5 divides a square. Okay, 5 divides a square. Then 5 divides a also. How? By the theorem 1.3, if p divides a square, p divides a. Okay, so by this theorem we can write like if 5 divides a square, then 5 divides a. Now 5 is a factor of a. So we can write like a is equal to 5 into any integer. That integer we are taking it as c. After this step we are squaring both the sides. A square is equal to 5c the whole square. Okay. Now it becomes a square is equal to 25 c square. Now compare these steps. A square is equal to 5b square, a square is equal to 25c square. So we can substitute 5b square in the place of a square. 5b square is equal to 25c square because a square is equal to 5b square. Now we can cancel 5 in both sides. Then it will be b square is equal to 5c square. Okay. Now we can compare these two. A square is equal to 5b square. B square is equal to 5c square. Okay. That means 5 is a factor of both a square and b square. A and b shares a common factor 5 by our proof. But what was our assumption? A and b are co-primes. They are not sharing any common factor other than 1. But now it shares the common factor 5. That means this contradicts our theorem. Root 5 is a rational number where root 5 is equal to a by b and a and b are co-primes. So we can conclude that root 5 is irrational. Okay. Here A and B share common factor 5. It contradicts our assumption that A and B are coprimes. Okay, so our assumption was wrong only. Hence, we can say that root 5 is irrational only. Okay, so hence root 5 is irrational. Next question, prove that 3 plus 2 root 5 is irrational. We already proved that root 5 is irrational. Now we have to prove 3 plus 2 root 5 is irrational. Note these points. Sum or difference of a rational number and an irrational number is always irrational. Product or quotient of a rational number and an irrational number is always irrational. That means always we are adding or subtracting a rational number with an irrational number. The resulting number will be irrational only. In the same way, the multiplication, division also, if we are performing with a rational number and an irrational number, the resulting number always we get as irrational only. Now come to the question. 3 plus 2 root 5. Okay, 3 is a rational number. Root 5 here it is an irrational number. Okay, so the product 2 is a rational number again. So 2 into root 5. Okay, 2 into root 5 is irrational only. And we are adding a rational number 3 with an irrational number 2 root 5. That also, the resulting number also, it will be irrational only. Okay, that is a logical thinking. But we have to prove this by using the theorem root 5 is irrational. So let us write the proof. Again we are using the contradiction theorem here. Using the contradiction theorem, let's assume that 3 plus 2 root 5 is rational. Okay, we are just assuming the opposite. 3 plus 2 root 5 is rational. If it is rational, we can represent it as 3 plus 2 root 5 is equal to A by B, where A and B are coprime numbers. Okay, now we can cross multiply this. Then 3 plus 2 root 5 into B is equal to A. 3B plus 2 root 5B is equal to A. 2 root 5B is equal to A minus 3B. Okay. Then root 5 is equal to A minus 3B by 2B. Okay. So this is a rational number. A minus 3B by 2B is a rational number for A and B are integers. But we already proved that root 5 is irrational. Okay, so this is rational and this is irrational. It cannot be happened. LHS and RHS should be equal only always. So it contradicts our assumption a minus 3b by 2b. Okay, this is a rational number. So 3 plus 2 root 5 is a rational number. That was our assumption. It was completely wrong. So we can conclude that 3 plus 2 root 5 is a irrational number. Okay. So a minus 3b by 2b is a rational number here, but it contradicts the theorem root 5 is irrational. Okay, hence 3 plus 2 root 5 is irrational. Okay, so this is the way how we will prove that 3 plus 2 root 5 is irrational. Question number 3. Prove that the following are irrationals. Numbers are 1 by root 2, 7 root 5, 6 plus root 2. First number is 1 by root 2. Okay. So, here we can assume that let's assume that 1 by root 2 is rational by contradiction theorem. Okay, if 1 by root 2 is a rational number, we can represent it as a by b, where a and b are co-primes. Okay, now we can cross multiply this. B is equal to a root 2 is equal to b by a. Okay, so b by a is a rational number where a and b are co-primes, but root 2 is an irrational number. We already proved it by one theorem. Root 2 is irrational. So it contradicts. This is rational and this is irrational. Okay, so it contradicts our assumption. Here b by a is a rational number, but it contradicts the theorem root 2 is irrational. Hence, 1 by root 2 is irrational only. Okay. Again, the next question, 7 root 5. Okay. So, first step, let's assume 7 root 5 is a rational number by the contradiction theorem. Okay, then 7 root 5 is equal to a by b, where a and b are co-primes. Okay, now we can cross multiply this. 7 root 5 into b is equal to a. Okay, 7 root 5 is equal to a by b. Root 5 is equal to a by 7b. If you want, we can write like 1 by 7 into a by b. Anyway, you can write. This is also fine. This is also fine. Okay. So, root 5 is equal to 1 by 7 into a by b. So, this is a rational number where a and b are integers. But we already proved that root 5 is irrational. So, it contradicts. Here it is irrational and this is rational. It is not possible. LHS and RHS always it should be equal. So, this assumption it contradicts our theorem. Okay. Here 1 by 7 a by b is a rational number contradicts the theorem root 5 is irrational. Okay, that means our assumption was wrong. So we can conclude hence 7 root 5 is irrational. Okay, our assumption was wrong, it was rational. So 7 root 5 is irrational. Then the number is 6 plus root 2. Again, we are assuming that 6 plus root 2 is a rational number. Let's assume that 6 plus root 2 is a rational number by contradiction theorem. So 6 plus root 2 we can express as a by b, where a and b are co-primes. Okay, now we can cross multiply this. Otherwise root 2 we can take it as, without cross multiplication we can perform this. Root 2 is equal to a by b minus 6. We can write like this. Okay, always keep the irrational number to the left hand side. Okay, so root 2 is equal to a by b minus 6. A by b minus 6 is a rational number where a and b are co-prime integers. Okay, but root 2 we already proved that root 2 is irrational. So again it contradicts. This is rational and this is irrational. So our assumption was wrong and we can conclude that 6 plus root 2 is irrational. A by b minus 6 is a rational number and it contradicts the theorem root 2 is irrational. So our assumption was wrong and we can conclude that six plus root 2 is irrational. Okay. Thank you for watching the video. Please like and share and don't forget to subscribe the channel to get notification for new videos.